as we fire up Unit 11 here, we're, of course, going to start with the notes. We got to have some examples to work with before we can do the other stuff. And so today we're going to lock in on two things. Excuse me. So how do I find the answers to these things called quadratic functions? And quadratic just means something that has x squared in it, okay? So we just got done graphing these. Now we're going to do the algebra portion. So when we're trying to find a solution to what's called a quadratic equation, the point where the parabola crosses the x-axis. So for instance, in the ones that I've got here for examples, okay, here's my x-axis. My answers here would be at -2, right there, and 1 over here. You're literally just looking to see where does my parabola touch the x-axis, and wherever that is, that's the answer, unless your parabola never touches the x-axis. That's going to happen sometimes. Yeah, no solution, none, whatever it happens to be. But it will always be one of those three options. There's going to be two answers, there's going to be one answer, or there's going to be no answers. So let's say I don't have a picture, or at least not right away like we did on these first examples. And so if all I'm given is an equation, I absolutely have the ability to go to my graphing calculator, just like we did before. Y equals is up here, okay? If there's stuff, we've got the clear button right above our exponent button here. So we'll kind of put, we might need the clear button. We're going to type this in. Now, we're not typing in the equals 0 part. I'll explain why we don't need that here shortly. We're going to type this part into the y equals, though. So just like we did before, and I'll put it here again on your new notes in case either your other ones get misplaced or something like that. When we want x, that's that button here with x, t, theta, n. Okay, that'll give me my x. We're going to type the x squared button here, the one that's kitty corner from 7. That'll get me my squared. Everything else is pretty much stuff we've done before. And again, we don't need the equals, we don't need the 0. And so once I get that stuff into my y equals, okay, I can take a look at the picture. I can hit graph here. And I notice my parabola is going through the x-axis in those two spots. Now, if I can visually see that, and maybe I can in this point, -1, -2, -3, -4, 0. When you're looking for an x-intercept, the 0 part of your coordinate will always be, the y coordinate will always be 0. There, I spit out what I was trying to say. And then I come over here and I also see my parabolas going through where x equals 1. Now let's say I can't tell. Let's say I'm not sure, I'm not confident. You also can look in the chart. So if I do second graph, I'm going to do that too. Yes. Just in case you don't have it here again, we'll jot this down. And what you're going to do if you go to the chart, you're going to go to the chart and you're just going to scroll up and down looking for where y equals 0. And if you happen to find where y equals 0, the x value is your answer. It's your intercept. So there, I can see in my chart -4, 0. We had found that one on the picture. And if I go down a little further, there is 1, 0, and there's my second intercept. So I can use my eyeballs, okay, and look at the picture, or I can use my chart. They both get me to the right answer, which is kind of nice to have a secondary option. So that's visually how we would do this. And we'll see more of those shortly when we're looking at some of the examples. My other option, if I don't have a picture, okay, is to set the y equal to 0, set each piece equal to 0, and solve using algebra. What's that look like? Okay, so we plug in 0 for where the y is at. That's my first job. And once I do, you take each piece that has an x, so x minus 3 equals 0, and x plus 1 equals 0, and you just solve the mini equations. So just like we would normally here, we do my opposite. And get my answer. I do my opposite. And I get my answer. But let me remind you, your answers are always going to be in coordinates. It's going to be the x value that you get and 0. So what I mean when I say that is, when I get these answers, don't leave these as x equals 3 and x equals -1. Those are axes. Those are vertical lines. What we want for answers is your x value and a 0. Your x value and a 0. And just to prove a point, if some of you liked what we did up here better than trying to do the algebra here, you're like, I like looking at the calculator, just looking in the chart. You actually do that for these. I don't personally suggest it because I think this is going to be quick. But if I wanted to, I can literally type this into y equals the exact same way I see it. So yes, I would need the parentheses. I could look at the picture if I wanted to, like we did on the last one. -1, +3. Okay? Or I could pull up my chart. -1, 0. Yep. 3, 0. Yep. And do it that way. So we got lots of options is what I'm trying to tell you with these. You don't have to just do the one way Hardy puts on here. You could do a couple different ways. And so this last one is the same idea. Each piece that you see here is going to get set equal to 0. Some of you either need an earbud with that if you're going to pay no attention and just go into stupidity, as I would tell my son, or you need to turn it off. I don't care which. But thank you in advance for your cooperation. 0 divided by 2 is 0. Get my answer there. Little more work on the second one. And just two-step your way through it. But as I said before, and I will say a lot in this unit, don't leave them as X's. If this were a quiz, I'd give you half credit. Gotta get the coordinates. Gotta do it. What we circle is what we're looking for answers. And as we said before, you may run into some circumstances, whether it's pictures or even algebraically, where you may only have one answer. Okay, or you may have things that just don't work. So, what would those look like? Let's check this out. So I'll bring those back up here shortly if we need to. For today, we are going to be dealing with page 1 and 2 in the practice packet. And like we were saying before, when we're dealing with, when you have a visual picture, I don't have an equation, I don't have a way to do it algebraically. All you're going to do is you are going to head on the x-axis. I'm just going to kind of highlight with my teal here. Yeah, and you're going to find on the graph where it's crossing the x-axis and write them as coordinates. Because again, the correct response for y on every single one of these is going to be 0. So if it goes through twice, I'm going to have 2 coordinates. If it touches it once, I'm going to have 1 coordinate. If it doesn't touch it at all, I'm going to say none. Because that's going to be the case at times. So nothing too terrible right there. But again, touching it is the same as going through it. So don't think, well, it doesn't go through and come down, so I don't know that. That one counts. Okay? But you're doing that. Now, what's that? Nope, the y-axis does not matter to us yet at this point. That's something different. No, that's not. We're not looking for the y-intercept when we're looking for solutions to the quadratic, but it can help us with graphing and answering some other types of questions. But not yet. You're ahead of the game. It's true. Number 2 will only have 1 point. It's true. Now, here's something we didn't see before on the notes, but we can handle this. Graph a possible quadratic function that has the given solutions. Okay. X equals 3 and x equals 4. So I'm going to go to where x equals 3. I'll put a dot. I'm going to go to where x equals 4. I'm going to put a dot. And similar to what number 1 looks like, I'm going to make a parabola that goes through the 3, and on my way back through, goes through the 4. I could make it pointing down. That would work. But I've just got to make sure it goes through both points. Yeah. Well, it's got to be a parabola. But yeah, it could be up or down. You could make it where it looks like it really stretched wide. That could work. But if it has 2 points, it's going to be going through. If it only has 1 point, it's just going to be touching it. Yeah, like it'll look like number 2 up above would. It's just going to touch. And then it's going to go back through. So, it's kind of making the connection between our answers and what the graph is going to look like when we're doing some of these. And so, as we flip to the back, oh, algebra. Okay. So when we get back here, solve each equation, show all the work. Okay. Remember, when we get back here, anything, I'm even going to write this up here, anything with x you set equal to 0 and solve. So when I get here, so even just the regular old x already, I set that equal to 0, I do. And I do the same thing with the x plus 3. You're like, Hardy, I can't do anything with that. It's x equals 0 already. You're right. So just make the coordinate, because again, it's always your x value and then 0, no matter what. And then you're right. And once we know what x is, we're good to go. So for any of these, whether it's just an x out in front, or you've got something, let's say, like 14, each piece gets there equals 0. Take your time in getting that x term isolated, doing our opposites. And when you get here, and I'll warn you, sometimes I go back and forth with this. I could leave that as a fraction for my answer, but I also see that if I divide it, it's 1.5. So I will do my best to remember to put things into the decimal, but if you do it sometime and you're like, wait, I don't know if my answer is the same, just punch it in and see if you get the same decimal. If you do, you're good. Get that one last piece taken care of here. Again, always into a coordinate when we're doing those. And then just a quick start reminder here on the very last problem. Especially if the quiz, the last one, was a struggle. I'll give you a hint, but I'm not doing it all. Remember, to find your axis of symmetry, you get your A and B values from the equation. You plug them into that little formula. And so your first step would be to find your axis of symmetry, which also will give you the x value of your vertex. And then to find the vertex, since you already have x, you can plug that x value in and find y equals, or, we've done this before, you can type this into your calculator and y equals, and go looking for the symmetry. They both work. So whichever one works better for you is what we're looking for. So that's all I've got. If I can help with scheduling for making up the old quiz or answer questions you had, what you might have missed on the last quiz, let me know. Tomorrow we'll have one more little piece before the testing on Wednesday. And other than that,